Hey everyone, today we're going to dive into 3 JavaScript array methods that I promise will fundamentally change how you write code: map, filter, and reduce. We're going to see how they can make your logic so much cleaner, more readable, and honestly, way more powerful.
So let me ask you a question. How many times have you found yourself writing a multi-line for loop for what feels like a really simple task? We've all been there, right? It's kind of the universal developer experience, but a lot of the time it's just not very efficient or clean. Well, there's a much better way.
Think about a super simple task, like doubling every number in an array. With the traditional loop, you're basically building this manual process from scratch. You create an empty box, you loop through every single item, you do a little math, and then you manually put the new result into that box. Yeah, it works, but it's a lot of boilerplate for a simple transformation.
So here's our game plan. We'll start with that familiar problem, then introduce the modern toolkit that solves it. Then we're going to do a deep dive into map, filter, and reduce, and we'll wrap it all up by talking about how to choose the right tool for any situation you might run into.
So, what is this better way I'm talking about? Well, it's all about using JavaScript's built-in higher-order functions. Now that sounds a little academic, but all it really means is that these are functions that operate on other functions. In our case, they let us tell an array what we want to do with its elements, without us having to write out the boring loop that does it.
And here they are, the stars of the show: map, filter, and reduce. These 3 methods are really the cornerstone of modern functional-style programming in JavaScript. Once you master them, you'll find yourself not only writing cleaner code, but also solving problems way more elegantly. Okay, let's start with map. The best way to think of map is as a transformer. Its entire job is to take an array and create a new, modified version of it, piece by piece.
So here's the crucial point. Map goes over every single element in an array, applies a function that you provide, and then it returns a brand new array with all the results. And this is important. The new array will always have the exact same length as the original one, no exceptions.
This slide just shows the difference perfectly. Look at that. On the left, you've got that verbose for loop. On the right, the map method. A single line like numbers.map num arrow num times 2 is incredibly clear. It basically says, take the numbers array, and for each num inside of it, transform it by giving me back num times 2. The intent is declared in one self-explanatory line. It's beautiful.
So let's just recap the essentials for map. First, it always gives you a new array back. It never messes with the original. Second, the new array's length is identical to the old one. And third, its primary job is transformation, changing each element into something else.
All right, let's move on to our next tool, filter. You can think of this one as the selector. If map is all about transforming data, filter is all about choosing which data you want to keep. The filter method also iterates through an array, but instead of transforming elements, it runs a test on them. If an element passes the test, meaning the function you provide returns true, it gets included in the new array. If it returns false, it gets left out. Simple as that.
And here again, the improvement is just so obvious. Instead of a for loop with a nested if statement, filter gives us one clean line. This code, numbers.filter num that num modular 2 is equal to 0, clearly states its purpose. Keep only the numbers where num modulo 2 is equal to 0. It reads like a rule, not a procedure.
So for filter, remember these key points. Like map, it returns a new array. But unlike map, the length of this new array can be smaller. And here's where the real magic starts to happen. You can chain these methods. Imagine you want to double only the even numbers. You could just do numbers.filter.map.map. See? That's how you build these elegant, powerful data pipelines. And finally, we have reduce, the combiner. This is often seen as the most powerful, and sometimes the trickiest of the 3. But that's only because it's so incredibly versatile. Reduce takes an entire array and boils it all down to a single value. That value could be a number, a string, or even a completely new object. The magic here is in the accumulator. Just think of it as a running total. On each pass, the accumulator holds the result of the previous operation, ready to be combined with the next element in line. Just look at this comparison for summing an array. The code numbers.reduce, a comma cur adding ac plus cur, 0, is so expressive. It says, reduce this array. For each element, take the accumulator, which we'll call ac, and the current value, cur, and just return their sum. Oh, and see that comma 0 at the end? That's our starting value for the accumulator. It handles the entire process in one go. The key takeaways for reduce are absolutely critical. It returns a single value, not an array. It relies on that accumulator to build up the final result, and you'll use it for anything that involves calculating totals, finding averages, or even grouping complex data into an object. It's a real workhorse.
Okay, so we've met the whole toolkit. Now for maybe the most important part. How do you decide which one to use? Honestly, it's simpler than you might think.
This summary table is basically your cheat sheet. If your goal is to transform data and you need an array back of the same length, you're going to use map. If you need to select a subset of data based on some condition, use filter. And if you need to combine all your data into one single output, reduce is your go-to. Let's turn this into a quick decision-making process. Just ask yourself, am I transforming every element into something new? Use map. Am I selecting a subset of elements based on some kind of test? Use filter. Or am I combining all the elements into a single final value? Well, that's a job for reduce.
Ultimately, what this all comes down to is writing better code. By embracing these methods, you're not just saving a few lines. You're writing code that is cleaner, more expressive, and way easier for you and your team to understand and maintain.
So, I'll leave you with a challenge. Think about the code you're working on right now. Which one of your 4 loops is just begging to be refactored into a clean, single-line map, filter, or reduce? Now you have the tools.